Hey, Vlad here, devinside.com. Welcome to another video. This is the second part of the video about the difference between objects and data structures, and in this one we find out when to use which, and most importantly, what happens if you choose wrong. As always, we're in the virtual machine and we have Sublime on the left and the regular GNOME terminal on the right, which runs SPT, which in turn runs our Scala code as soon as we save a file. I already mentioned in the previous video that objects are all about behavior. They expose methods, which is behavior, and hide data, which is variables internal state, right? And the data structures are diametrically opposed to objects. They expose data, and it's not that they hide behavior, it's more that they don't even have behavior, and if they do, then the behavior is usually navigational, and most importantly, it doesn't contain any business rules. Now, all this sounds fine and dandy, but what does it actually mean? Especially, what does it mean in terms of their usage? Are these two concepts interchangeable? Are there differences? Can we use them the same way? Let's see about that. And by the way, most content in this video is inspired by an 11-year-old blog by Uncle Bob Martin, and the link is going to be down in the description. One of the canonical examples for this discussion is the geometric shape. So we're going to have an abstract class shape, and the first version that we're going to write is going to be the object way of writing it. So we're going to have an abstract class shape, and it could be a trait, but for our discussion it doesn't really matter actually. And the only thing that it will have is it will know the area of the shape, right? So it's just going to be a double, and it's going to be an abstract method, right? And now we're going to have a few shapes. So we're going to have a class circle, and it contains a radius, which is a double, and it extends shape, and it overrides. We could actually override it with a val. It doesn't really matter in our discussion this time. Double. I'll actually use it. Let's use a def, because then the syntax highlighting in Sublime works a little better. All right. So this is the area of the circle, and in order to calculate that, we do 2 times math dot pi. And by the way, the lowercase math object comes from the Scala standard library, because the one in the Java standard library is setting was an uppercase m, right? So the one from the Java standard library would look like this. Okay, right. So this is a circle, and we're also going to have a rectangle. In fact, let me duplicate this line. Let's bring it down, and this is going to be a rectangle, and it's going to have a width, which is going to be an integer, and it's going to have a height, which is also going to be an integer, right? And whoops, that's not what I wanted. Let's close the brace. So now we're also going to override def area, which is a double, and the area of the rectangle is just width times height, right? So this is the whole example, and what we're going to do is we're going to instantiate a few of them. So we're going to have a circle, and this is the important part. The type of the circle is going to be shape, not circle. So it's going to be a circle with a radius of, let's say, 5, and then we're going to have a rectangle, which is also a shape, and we're going to have a rectangle, which is, doesn't really matter, let's say 10 and 20. I'm going to format it like this just because I can. There we go. Okay, so now print line circle dot area and print line rectangle dot area, and let's see if that works. Okay, so it looks like it works, and the exact numbers are actually they actually don't matter in this discussion. It doesn't matter if we calculated the area right or wrong. We're not talking about this at all. So remember in the video about dependency inversion, we split our project into multiple ones, and then we were publishing jars, and then we taught SPT how to fetch them, how to find them. In this case, in this video, we're going to do something very, very similar, but we're going to use a more convenient way of managing dependencies. So in this other video, we were using the so-called binary dependencies, right? Because we're using jars, and in this one, we're going to use source code dependencies. So we're going to teach SPT how to build multiple projects at once. So this way, we won't even need to publish anything and to define it later or something like this. So what we're going to do is I'm going to right-click here, and I'm going to open the containing folder, and I'm going to go to dev. So this is where the entire project is. So what I'm going to do is I'm just going to copy it, and I'm going to paste it over here, and I'm going to call it Multibuild. It doesn't matter how you call it. I'm just gonna call it Multibuild. And now what we will do is we will go into Multibuild, right? And just because I want to avoid having problems with it, I'm gonna delete the target folder, and I'm gonna go into project, and it also contains a target folder. I'm also gonna delete it, and we're gonna go even further into project, and we're gonna remove the last target folder, right? So the target folders are gone. And remember, in the very one of the very first videos in the Scala playlist, I explained to you that SBT compiles everything into this target folder. So these target folders will be regenerated every time. All right, so what we have here is source and project. So this whole thing is one project, but I want to have multiple projects inside of it. So what I'm going to do is I'm just going to create a folder, and we're going to have a folder called library, which is going to be one project, and we're going to create another folder called application, and the application will depend on the library, right? The application will use the library. And as of right now, I'm just going to copy, actually I'm going to cut out the source file, because right now we have three projects. We have the root project, we have the application project, and we have the library project. This is very common, by the way, and it's also very common not to have anything in the root project, right? So we're going to cut it out, and we're just going to put it in the application, right? And this is enough for now. So all I will do now is I will open Multibuild with Sublime. Open with Sublime Text. Next thing I'm going to do, I'm going to close that, and now we have Sublime over here. And just to avoid confusion, I'm going to go to the second workspace and just put it over there. So we're still like in the very first workspace. We have our Sublime on the left, we have our terminal on the right, but this is a different project, right? So this is the Scala playlist project. And now we're going to go here, and this is going to be just Sublime, and I'm going to maximize it, and I'm actually going to make it full screen. So if I press Control KB, then we'll actually see our folder structure over here. So we have project, which contains build properties, which contains just the SPT version, and then the plugins.spt, which contains the SPT revolver plugin that we used in the recursion video. We don't really need it for this video, but I'm just going to leave it there. And then we have application and library. Application already has our main method, which is just copy pasted, right? So now all we need to do is we need to go to build SPT, and we need to teach SPT that this is actually not only one project, but this is actually a multi-build project, was multiple projects inside. So we go to build SPT, and I don't want to concentrate this video on SPT, so I'm not going to explain this in very much details. SPT follows a concept called convention over configuration, which means that if by default you don't provide any configuration, there's already a default configuration, which is the convention of the of the industry. So by default, what SPT will actually do, it will do something like this, because the configuration of SPT is also Scala code. So it will do something like lazy val root equals project, dot in file dot. So this is what is happening by default. In our case, we're going to do something similar. In fact, I'm going to take this, I'm just going to copy paste it and put it over here, and we're going to call this one library. We're going to start with the library, and the library is going to be under, not on the dot, but it's going to be on the dot slash library, and we're going to have the same thing with the application, right? So I'm going to have it over here. What is paste it like that over here? Come on. All right, there we go. So now we're going to have application, and we don't need root. I just use it for demonstration purposes. There we go. And there's a typo. Hold up. Application. All right, there we go. Now all we need to do is we need to tell SPT that the application depends on the library, and we do this by literally saying dot depends on. And by the way, this is literally just Scala code, right? So there's an object somewhere called project. There's a method called there's a method called depends on, right? So it depends on library, which is this one. By the way, it's very common to define them as lazy vals and then just use them wherever in this file. Okay, so we're almost done. The thing is that all of these settings, except for this one, which is the one that when we use continuous compilation, that it clears the terminal. So except for this one, all the other ones, like the version, the Scala version, and so on, they're used only for the root project. And if we wanted to use them everywhere, we would need to add this thing like that. In this build, in this build, in this build, and in this build. Save. Now, usually we have Sublime on the left and we have the terminal on the right, but in this case, I'm going to keep Sublime on the top like this. And I'm going to open another terminal, and I'm going to put it down like this. And I'm going to go here into dev Multibuild. I'm just going to start SPT. And now what we can do is we can say compile as we were doing, right? And then compile will basically go through all the subproject and compile them, all right? So in our case, we only have content in the application project, which is why we see that it compiled on the application. What we could also do is we can type projects, right? And it will show us with the star that right now we're in the multi-build project, which is the root project. But we can also switch. We can do project library, for example, right? So set current project to library. So now if we say projects, we see that we're actually in library, and we can go to project application, and we're going to say ~run, and we have our application from the beginning. And the cool thing is that if we go to the library, and no, I'm sorry, did I forget to minimize Sublime? Hold up, like this. There we go. So if we go to the library, for example, and we create a folder with the same structure, we're going to create source main Scala. Right? And we're going to create a file there. I'm going to call it shape. We're not continuing with our example yet. I'm just showing you something. So because we created just another file, and we're doing ~run in our application, because the application depends on the library had to be recompiled, right? So every time we add, like, I don't know, an object here, object blah, right? We save the file, and the library needs to be recompiled. And it doesn't matter if the application needs it or not, because the application project depends on the entire library project. Whatever we do there will cause a recompilation in the application project. Now let's remove that, and before we continue with our example, I actually want to go back to build SPT and add a few more things that they're just going to help you to understand better this whole dependency situation, right? As I already said, I don't want to make this video super SPT centric, so I'm just going to copy paste some stuff. So we're going to have a function, a regular function called fancy prompt, because over here this greater than symbol is the prompt, and every time we press enter we see the prompt. Like, this is what a prompt is for, right? But what we can do, and by the way, Control L should clear this, right? What we can do is we can override the prompt, and this is what we're going to do. So I'm just going to copy paste a def called fancy prompt, and it's just a regular def. You give it a project name, and it just creates this beautifully formatted string which says welcome to the project name project, and it calls this method called sign, which is the method that I'm also going to copy paste. Like, usually I would type them all out, but I just don't want to waste your time. So it's just going to prepend those ANSI codes that I mentioned in my videos already quite a few times, right? So now all we need to do is we need to use this fancy prompt, and the way we do this is we configure shell prompt for the root project by using it over here, right? And the thing is that we also this does not propagate to the others, right? So usually, as I already mentioned, we would do some like in this build, but this one is a bit more complicated than just simple strings that we have over here, right? In fact, this dot value is a very complicated thing. So I'm not going to explain this any further. All we need to do over here is we need to say dot settings, and there's a parameter we need to paste the whole thing again. And I'm going to duplicate this, and I'm going to send this to the application. Right, and let's see what it gives us. So we can reload, and now it says welcome to application, and we can do project library, and we'll say library, and every time we press enter we will see this prompt again. And yet another thing that I'm going to copy paste is a few aliases. So SPT allows you to define aliases, and I'm going to paste them. Where should I paste them? I'm going to put them over here. So now I'm just going to reload, and as you can see, for example, if I say app, it will do project application. So now I can just do app, and it switches to application. I can do just lib, and it switches to project library. And the same way, instead of saying project application, which is, you know, a bit a lot to type, I can just do cd application, right? I can't mix them. I can't do cd app, right? But I can do cd application. Also, I can go back to the root project by just saying root. You have no idea how many times it happens to me that I forget that I'm inside of SPT, and I'm sort of trying to switch folders, and I'm doing like change directory, you know, application, right? And then SPT says, you know, cd is not a known command. This is why, like, usually in my projects, I do this. All right, so this is enough. Let's continue with our example. So in fact, if we do this ~run thing, we're actually unfortunately not even going to see our prompt again, because, you know, we're not typing anything, right? So every time we can close this actually. Every time we save something, Right, it's just gonna recompile, or in this case, it didn't even need to recompile. So we're gonna do object shape over here, right? And in fact, let me just copy paste it. So what I want to do is I want to cut out this thing. I want to cut out this abstract shape. So now it's not gonna work. But over here, if I paste it in, why does it do that? Hold up. All right, there we go. So abstract class shape. So it's in the library, and in the application we have the circle rectangle, and we have our print lines. By the way, I hope it's clear, but the dependency goes only one way, right? So in our build, we said that the application extends, that the application depends on the library, but not the other way around. Which means whatever we define in the library, we can use it in the application, but not the other way around. Now, even though this is very intuitive, this is actually a very important topic for today, which means that whatever I do here, right? So if I say print line hello world, well, we'll see down there, we'll see exactly what is being recompiled, and only the application is being recompiled, not the library. Okay, this means that if we add another shape, right? So if we go here, let's duplicate this line, for example, and we're going to call this a triangle. We're going to have a triangle. There are many ways to define the triangle, but we're just going to have a base, and we're going to have the height of the triangle, right? And if you wanted to calculate the area like this, if you construct a triangle like this, then calculating the area is very similar to calculating the area of a rectangle, right? So all we need to do is we need to base times height, but because a triangle is basically the half of, sort of like the half of the rectangle, we need to divide it by 2, and before that we probably should convert this to a double, right? All right, but again, in this video, it doesn't really matter if we calculate the area correctly or not. So now I want to use the triangle the same way as we're doing it over here. And by the way, I'm starting to feel sick again, so sorry for my voice. I'm starting to lose it again. All right, so we have the shape triangle, which is a new triangle. And let's do, it doesn't actually really matter, but let's do the same thing as with the rectangle. Okay, and now we can go down a little bit more. We can just copy that, remove that. We can go here, use the triangle, right? Now, before I save, again, it's really important that you see that the library is not being recompiled. Let me save, and we see that only the application is being recompiled. And this is very, very interesting. And why is this interesting? I mean, we already learned about the dependency inversion and the benefits of it, but in this video, we're sort of looking at this from a new light. Now, because the library does not need to be changed, because the source code of library does not need to be changed, it means that it doesn't need to be recompiled. It doesn't mean that, it means that it doesn't need to be retested, repackaged, republished, redeployed, and all of this stuff. In other words, it doesn't need to be rebuilt and redeployed. This is also known as the open-close principle, which is one of the 5 solid principles of object-oriented design, which is a topic for some other video, of course. Objects like shape are said to be open for extension, right? Which means we can extend shape with different classes, right? But they're closed to modification, which means we don't need to change the source code of shape in order to change the behavior of area, for example, right? So if you wanted to change the behavior of area, we'll just create a new shape and it will have a new area. Now let's see what happens when we add actually new behavior. And in fact, you know what? I should probably split Sublime into 2 projects. So we're gonna have library on the left, and we're gonna have the main with application on the right. Oh my god, I'm sorry for my voice. So adding new behavior means that we're going to add a new method. So if we go to here, and let's add a method called, I don't know, scale. I constantly keep typing Scala. So it's gonna get a factor of the scaling, and it's gonna return a unit. But again, like most of these details, they don't really matter. It only matters that we're adding a method, okay? And let's say that it's going to be already an implemented method. I'm gonna do something like scaling. Okay, so notice that if I save now, it will actually, we're changing the source code of the library, and even though we're not using scale in the application, because we're compiling the application, we still need sort of this new version of the library. I hope I explained this properly, because actually what we can do is we can go back to the library, right? And we can do this whole, there's no main method, so we can just keep compiling the library, right? So I can just remove that, right? So we're recompiling the library, but now we're not recompiling the application, right? So maybe I confused a bit before, but the idea is that your application always needs the latest version of the library, right? So in fact, I'm gonna go back to the app, and I'm gonna do run. See, those aliases are already worth having. All right, so let me add it again. Scale, and again, recompiling the library, recompiling the application. So it seems like the object approach is immune to adding new types, but it has problems with adding new behaviors. And if it's even more clear if scale was an abstract method, right? So if you remove that, right, now it's even more clear, because now all of our objects are not going to compile. It's going to say, for example, class circle needs to be abstract since method Scala, sorry, I keep saying Scala, since method scale and class shape of type vector double unit is not defined. Well, it is correct. So we have to go everywhere, and we have to add this scale method, which is a gigantic maintenance cost. And by the way, one other thing, in practice, it's actually kind of hard to design systems with the open close principle in mind, because, for example, let's say even before we added scale, let's remove it. So for example, if the developer who is designing this abstract class shape, if he's thinking only about like rectangular shapes, like, rectangle, square, maybe, like some sort of hexagon, which is not rectangular, but, at least it has angles, right? Then he might have designed it like this, right? He might say, oh, it sounds like, all shapes, their area can be calculated in terms of integers, right? But then once the shapes are actually implemented later, you see, oh, by the way, we have a circle and it has a pi, and then the radius is probably, because of the radius and because of the pi, the area should probably be a floating point, right? So now we have to go back and to change the library. And we just saw what is happening, right? When you change the library like this, every application needs to be recompiled, retested, and redeployed and everything. Also, just as a sidebar, let's play around with this, because inheritance is set to be fragile. For example, let's say that let's remove that. Let's say before we added scale, let's say, because over here in the application we know that the library does not have a method scale, right? So but we actually need it. Let's say we wanted to scale a circle or a triangle, doesn't really matter. So we would go here, right, and we just define it ourselves. We're gonna do scale, and we're gonna do vector double unit print line, scaling the triangle. Let me do this like that. In fact, let me do this. Scaling the triangle by the factor of a factor. By the way, you see that the syntax highlighting is broken. It's because we forgot to add the s, because it's a string interpolation here, right? So let's say we do this, right? And now we still can't do triangle dot scale, right? By factor of, let's say, 2, right? Because the triangle over here is a shape. So what we're going to do is we're going to copy that. I'm going to call this T, and I'm going to call this triangle, and we're just going to use T over here, right over here, and now we can use T over here as well, right? So now we can scale the triangle. Now let's see what's going to happen if we actually define scale and shape like this. So we're going to do this, right? And the other two are not going to compile, right? Because it's going to say, they need to be abstract because the method scale is not defined, but the triangle is sort of fine. So in this case, we sort of got lucky, right? But in fact, you know what? Let me comment them out. Let's get rid of the circle rectangle over here, circle rectangle, because I just wanted to compile like that. All right, so we just have the triangle, right? So now we sort of got lucky, and we did not introduce any issue. But let's say if, we got lucky because we matched the entire signature. But let's say that the library did something like this, int over here, right? Now it's going to say overriding method scale in class shape of type vector double int, method scale has incompatible type. And we go, oh yeah, okay, so this is the incompatible type, so let's fix it over here, even though, so our application is kind of broken, but it's not a big deal, we can just do int now. And I guess we have to return the factor or some integer, because we're sort of forced to return this integer, right? And now it says, oh my god, no, but this is a double, and now we have to convert it back to int. It's a pain in the ass. And by the way, notice what will happen if we don't specify the type, right? So over here we're returning an integer. Over here, what's going to happen? Let's see. It says found double required int. So basically, we will constantly run into issues like this. And by the way, this is also why it's always recommended to specify the types over here like this, right? And it's also always recommended to do override, but we can't do override like before, right? Before we added scale to shape, right? You know what? Let me remove this whole scale. So this was just a sidebar, and it kind of went too far. I didn't want to do it so far. So what did we have here in the beginning? I think we had a unit, and we had some like print line. scaling, something, right? There we go, and let's enable our shapes like this, and like that, and like that. And let's remove the, let's do the whole triangle thing like this again, like that. Okay, let's remove that, remove that. There we go. Okay, so what we learned is that the object approach protects you against adding new types, but it has problems with adding new behaviors. And by the way, the same as I mentioned in the previous video, look what is happening with equality, right? Let's just do it for fun. Let's do print line new circle 5 equals circle, and in Scala, if you don't remember from the previous video, this is same as equals, plus you get a warning if Scala is sure that if Scala is almost sure that they're never going to be equal, right? And then we're going to do the same thing over here. Sorry, I wanted to duplicate the whole line like this, and over here we can do equals, and let's do it again, and we're going to do EQ. So equals is the same as this, and EQ is the same as, well, it's not the same as, it's the reference equality. Okay, and let's also do that like this. Okay, so it kind of looks more like shape. Okay, and let's also do print line like this, and we're gonna do circle equals circle. In fact, let me have also, sorry, over here, I'm in an empty line, so we're gonna have circle equals circle, and over here we're gonna have EQ, the same as at the top. We're gonna do this, and that. All right, so the first one should all be true. Should all be false, and the other one should always be true. And by the first one, we also get the warning. 2 warnings found. Oh, actually, EQ also gives you a warning. That's kind of cool. So it says that they're never going to be equal, right? Comparing a fresh object using equals will always yield false. All right, so let me revert that, and let's now see what is happening if we're using the data structure approach. So in order to do that, we're going to rename shape to shape 00, and we're going to fix it over here. Shape 00. All right, there we go. So what I'm going to do now is I'm going to duplicate this main probably. Yeah, I'm just gonna copy that, and I'm going to call this also main 00. And by the way, I should probably also rename the files. So let's do that. This one is main 00, and I'm gonna leave the shape like this. What do we need? We need to create another main, right? So we need to create main ds.scala, and I'm just gonna paste everything in, and I'm gonna remove all of that, right? So we're just gonna have a print line hello world over here, and everything should still work. Now I forgot to comment out this one. There we go. So we want to do the second one, and let's also call this one main 0. This one is called main ds. All right, so now we're running main ds, and it says hello world. So the data structure approach is going to go like this. We're going to have an abstract class again. I'm going to call it shape ds, like that. It's actually not going to contain anything. So now what we're going to do is we're going to go to our circle, and we're going to copy it like this. And we're gonna we already learned that we need to use case classes for data structures. So we're gonna do final case, and then paste it. Let me actually do this so that you see everything. Extend shape, in this case ds, right? And we're gonna do the same thing with a rectangle. Just gonna copy that. I'm gonna do final case paste. Sorry, class. Forgot to copy the class. Extend shape ds. All right. So now in the application, which is over here, right? What we'll do is under main ds, we're going to create another object, and we're going to create it object shape ds operations. Right, let me scroll down a little bit. So we're gonna have define area, right? Area, which is gonna take a shape as an argument, right? And we're gonna use a double over here, and now we have a problem, right? Because a shape, it doesn't have any, you know, any data, sort of any data, any behavior. It doesn't have anything, right? It's just an empty abstract class. So now we have to figure out which shape are we dealing with, right? So we need to do if shape, let me remove the cursor, is instance. We did something like this already in the video about subtype polymorphism and inheritance. We did something like this already, and we also know that there's a better syntax for this, which is called pattern matching. But we're going to talk about this in a second. So we have this, and now we can actually have a circle by converting the shape into a circle, right? And now we can do the same thing as we did before, right? So in fact, I can go to the main over here, and we're going to just copy that from here, right? And then we have to say circle.radius. And now we're going to copy paste that over here. I'm going to say else paste like that. And now if it's a rectangle, whoops, not there, rectangle like this, like this, like this, but here's the lowercase, right? Then I'm going to do rectangle dot width times rectangle dot height, and like this. And otherwise we're just going to do system error, not a shape, right? This should compile for now at least. Yeah, okay, it compiles. So we're basically pattern matching on the shape, and then we calculate the area, right? So let's actually use that one. So we're going to go into our code over here, and we're going to do basically same as before. In fact, we can actually copy paste that from here, these two, over here. Hold up, let's do that. Okay, let's do this. In fact, it jumps around so much. I'm gonna do this, right, like this. Okay, so we have our circle, we have our rectangle, and they're all the way to the right like this. Because we're using case classes, we don't have to use the new keyword like this. Okay, so we have our circle and we have a rectangle, and all we need to do now is we need to print out this dot area, and now we can give it the circle and copy paste that, and now we give it the rectangle, and now it should be fine, except for the fact that I copy pasted wrong. So we don't need the OO here, we need the DS, right? But everything else should be fine. It's the same numbers. Now, code like this is usually being frowned upon, right? Because it's not really object-oriented. These days, not being object-oriented is not good. In fact, these days, not being functional is not good. But in any case, we shouldn't throw out this style, because it also has benefits. Look what's happening if we add another behavior, right? So before was the object-oriented style. Basically, when we would add a new type, it was easy, right? And I already mentioned that the data structures are sort of diametrically opposed. So over here, adding new behavior should be easy. Let's try that. In fact, what I'm going to do is I'm going to maximize Sublime real quick, like this. And I'm going to just copy that and paste it over here, right? And I'm going to do our scale thing, scale, which takes the shape, and it also takes the factor. Whoops, what just happened? Like this, and it also takes the vector, which is a double, and in this case it produces a unit. So we have to do this whole pattern match thing again, obviously, right? And over here we're going to produce a result, which is going to be a string, and over here we're going to print out the result. And I'm just gonna copy paste this result because I don't want to lose your time, waste your time. I'm sorry. So this is the result that we want. Something like scaling circle radius is now circle dot, because I wanted to have an example which actually accesses the field on the circle, right? And over here we're going to do the same thing, right? So let me actually just copy paste that. I'm gonna have that, which is over here, and now my face covers it up, right? So we're just going to calculate the result like this, and otherwise we're still going to say not a shape, or we should actually say unknown shape, because you never know, unknown shape. and same thing over here, unknown shape. Right, so let me minimize Sublime again. So now if I save and I did everything right, notice again the library does not need to be touched. So let's use them now. Let's go to our code. Let's have an empty line, and let's just copy that, paste it over here. So now we're going to use the scale method, and we're going to have some factor over here that we're going to define over here. Vector equals 2, and if we run it, we should see some like scale in a circle. Oh, okay, let's also have a print line over here so that it's more evident like this. So we're going to see scale in a circle, radius is now 10, whatever, scale in a rectangle, width is now whatever, right? So so there you sort of have it, right? So adding new behavior is easy. Let's see what happens if we add a new type. So let's just duplicate the rectangle, which is something that I should have done before as well. So this is basically a triangle, right, with a base and a height, right? So now we add this, and now everything, it sort of looks fine, right? But we don't even see that we actually have problems now, right? So if I create another triangle like this, triangle, right? So if you try to calculate the area of a triangle, what do you think will happen? Oh my God, what's happening? Triangle. There we go. What do you think will happen? Well, it's going to throw the exception. It's going to say unknown shape, right? Over here, it is an unknown shape. Now we need to go through every single algorithm that we have and fix them. And by the way, this is only an educational example where we have only 2 algorithms and they're at the same place, so it's kind of easy to see them and to fix them. But in a real-world application, you're going to have hundreds of them spread all over the place. And the same thing would happen in the object-oriented system. You're going to have those objects flying around all over the place, right? So again, these two concepts are diametrically opposed, right? So in an object style, adding new types is easy, right? So when you're designing a system in an object style, you should probably design it in such a way that in the open close principle, right? So that in the future you will add new types and everything will just work out. Whereas with the data structures, it's the other way around. You should design it in such a way that your types are not going to grow, but your algorithms are going to grow. And we're going to discuss this by the end of this video. Right now, I want to point out the big picture right here because it's very important. Notice that the object-oriented way that we used here, it seemed like it has a better support from the language, right? And this in fact is a decision of a programming design, right? So there are many aspects to designing a programming language, and sometimes you can make a choice. Like, do you encourage just one style, right? Basically by forbidding the other one, or by making it like really uncomfortable, or do you make your language like very flexible and you give the developer the choice? Now we're not going to talk about which one is better. All I'm going to say is I'm going to compare Scala to Java. So Java basically encourages you to do only the object-oriented style because it doesn't provide any tools to deal with data structures, whereas Scala does. We haven't used them yet, right? Because I just wanted to arrive there slowly. But in fact, Scala has so many wonderful tools to deal with data structures that people have started to wondering actually why we need object orientation. In fact, I'm gonna leave a link down in the description for a Stack Overflow question where a guy basically was saying, hey, pattern matching is so awesome. Why do we even need subtype polymorphism? Right? Link is going to be down in the description. So first, let's introduce pattern matching, and let's see how everything gets better. We already stumbled upon pattern matching many times, and in fact, soon we're going to have a video which explains pattern matching in detail. Right? For now, let's just fix everything. So we're going to go to. So we still have our triangle, right? So let's actually. I don't want to implement the triangle. That's sort of not the point. Let's go down, everything is fine again, okay? So let's go down, and instead of doing this whole if else is instance of blah blah blah, we're gonna have a case here, we're gonna have a case here, and we're gonna have a case here, right? And then instead of this over here, probably was the over here, right? We're just gonna do circle, colon, circle, arrow to the right, and we don't need this one. And same thing over here. Like that. We have rectangle, like that, and the default case is this, right? So it's exactly the same code, but I forgot to match. I always forget to match on the shape actually. like this, match. There we go. This is why it's called, you know, pattern matching. We're matching on the patterns. And I forgot to remove the curly brace. Come on. What is happening? Okay, legal start a simple expression. Okay, shape match, case circle, circle, blah, blah, case rectangle, rectangle. It looks right. What are we doing wrong? 37, 37. Oh, I forgot an underscore. So this is the default case. So this line over here is doing if shape is instance of circle, then cast shape into a circle, and now we have this variable, and it sort of looks like a regular function. In fact, we'll find out really soon that it is actually sort of like a regular function. You know, we have a parameter here which is of type circle, and on the right hand side we can use it, circle. Right now, I don't want to waste your time and fix the scale over here, so I'm just going to collapse it and just going to comment it out completely, and we're just not going to use it for now. Where is it? Over here, like all of that stuff. Doesn't really matter. Okay, so now it compiles. So the next thing that we're going to use, which you know improves dealing with data structures. We already used two, right? We already used case classes, which by the way provide you with equality. Let me go to this thing where we had. Okay, we don't have it anymore. Let me actually copy paste that. So we have it over here, and I'm just gonna paste it over here, for example. Right, we essentially get equality for free, right? See, circle is the same as circle, circle equals circle, same thing. It's different references, right? So it's different objects. So this is why this one is false, but these ones are all correct. So we get it sort of for free because we're using case classes. And the next thing that we're going to do is we're going to seal the hierarchy over here. So we're going to have a keyword called sealed here. I'm not going to save this file because I sort of want to get rid of this equality for now. Like this. I'm going to save this one. So before I explain what the sealed keyword is doing, notice that in the object-oriented style, we had our types living in the application, right? And we had our sort of our behavior living in the library. And with data structure, it was the other way around, right? We have our data structures over here, but we have the behavior in the application. Or explain this in other words, the superclass usually does not need to know. It actually is not allowed to know about the subclasses. If it does, then you will run into issues actually. And what happens with data structures is actually it's the other way around. Like everything is the other way around. So sealed means that it can be extended, but only in the same compilation unit, and usually the same compilation unit means in the same file, right? So basically, the superclass shape.ds knows about every single instance of the subclasses, right? Because we're using sort of data structures here, but we're using them in an object-oriented way because Scala blends those features together, which makes it also kind of hard to see, right? Which is why I'm one of the reasons why I'm making this video actually, right? So sealed, what sealed will do, because now the Scala compiler knows about all the instances. If you forget to match on one of them, right? So if I remove this default case over here, look what's going to happen. Now we get a warning. So without the sealed keyword, we don't get this warning, right? Because now Scala doesn't know that we're actually doing this data structure dance. And by the way, it's also known as an algebraic data type, or ADT. And you don't need to know exactly about what it is, but basically it's a definition of a type and multiple ways of creating it, multiple ways of constructing it. So this whole thing is basically an ADT, right? So in this case, it says, okay, hey, you have a pattern match, but it may not be exhaustive. You forgot one or more matches. In this case, it says it would fail on the following input triangle. You don't have this in a language like Java, for example, that encourages only one of those styles. Right, so now let's try to make sense out of what we learned. I want to try to answer two questions. The first one is when to use which style, and the second one is what are you going to do if your language does not support one of those styles? Okay, so the first question, when to use which? I hope it already became evident, but basically if you're designing a system and it's clear that new types are going to be added in the future, then go with the object-oriented style. However, if it's clear that you have just a few types and maybe you're going to add like one or maybe you're going to add two, but mostly you're going to be adding new behaviors, then go for the data structure style. Before I can give you a few examples, I want you to listen really, really carefully because this is important. The domain alone does not decide for you which style to use. For example, the domain over here is math, or to be more specific, more precise, it's geometry, right? So you can't say, oh, so you're doing something with geometry, huh? Okay, so you have shapes, huh? Okay, so use the object-oriented style. This is not how it works. You always need to know your use case. What application what are you actually building your application for? For example, actually, let me do this. Let me open my browser, which opens over here. Let me go to draw.io, which is the application that I use for when I want to make some charts, and I'm just gonna say create a new diagram, right? Doesn't really matter, business, whatever. Okay, create. So as you can see, they have a lot of geometric forms, right? And I could just throw them in. But what can I do actually with those forms, right? I can change, the background. I can change the size, But that's basically it, right? So they have like maybe, I don't know, like 10, 20, maybe 30 things that I can do with a form. But they will keep adding new forms. Look how many forms I have, more and more forms, and they will keep adding them in the future. So I hope they implemented it in the object-oriented style, right? Because otherwise the maintenance cost is gonna rise. So it's gonna be so high that your project might even fail. Let me collapse that again. On the other hand, if let's say if you're writing your master thesis or your PhD, and you're writing it about also geometric shapes, and you need to prove, I don't know, something. So you need to do like a lot of different calculations with shapes. But for your thesis, it's enough for you to prove it based on, I don't know, 2 or 3 shapes, right? Then it makes sense to go for the data structure style. And this is basically it. But it's very, very important. Just knowing the domain or being the domain expert does not, give you this decision, provide you with this decision for free. You always need to care about the use case. Like, what are you actually what do you want to achieve? Additionally, and I hope it's clear by now, you can't just go and use pattern matching everywhere because you fell in love with it, right? It's the same thing. You have to sit down and you have to analyze your use case. You have to evaluate everything. You have to evaluate the probabilities of what's gonna in which direction is your application going to grow, and only then decide. All right, so I hope that I managed to convince you that this is an important topic. And before answering the question what to do in a language like Java, which encourages only one style, I sort of came up with a different question. So it seems like we can either add types or we can add behavior, but we can't do both. This is a good question. Can we actually have our cake and eat it too, right? Can we have some fancy programming paradigm or design principle or some built-in syntax that will allow us to do both? And the short answer is no. At least not in a statically typed language. And the long answer is still is that it is still an area of active research, and there are ways to mitigate these issues. In fact, Martin Nudersky, who is the creator of Scala, has published a paper about that, which I'm going to link down in the description. But again, the short answer is basically no. But there are a lot of really cool design patterns and principles that make the situation actually kind of manageable. So don't worry too much. By the way, in academia, the problem goes by the name of the expression problem, because the original example to illustrate this program was an example like this, where mathematical expressions were used. It's also a pun about seeing how expressive your language is. So it was a data structure which was similar to this, like similar to our shapes. It was mathematical expressions, and so you have an expression, and then you have an expression like plus, it extends expression, takes 2 other expressions and adds them together, produces an expression, and so on. So this was the original example. All right, so what do we do with languages like Java that don't support, they don't have good support for the data structure style? Well, basically what you need to do is you need to merge your behavior with your types, right? Because basically every problem that you have now, you have to structure it in such a way that adding new types should be easy, right? So instead of having a class like shape OO, what you should have instead maybe is, I don't know, let's have an trait, could be an abstract class as well, just to mix things up, a trait area, and it will have area double, right? And then later you can also have a trait scale, and it's going to have scale, right? Vector double unit. Okay, and then what you will do is in your application, you will go here. Let me actually come down this whole thing, and let me go here and enable this one. Okay, now everything works. So now what you will do here is, instead of extending a shape, right, because you're not dealing with shapes anymore, right, we're dealing with something like area. So you're gonna do area here, right? Area area, and over here as well. So they're areas now, and now because they're areas and not shapes, you probably should also call them differently. You probably should call this circle area, and rectangle area, triangle area, and so on. And let's do this here as well. Area, right? And now you have a choice. You can go and create, for example, let's go here. Let's just copy that, right? And now let's have a scale over here. Right, so now you're sort of growing behavior, but your behavior is types, right? So you extend scale, right? And you have your scale here with vector, which is a double, and produces a unit, and you can do your whatever, scaling a rectangle. Right? It's going to compile, it's going to work, or you can decide, okay, I can merge them together, right? Because it's traits, so I can extend the area with scale, and it would work in Java as well, right? Because these are basically interfaces without implemented methods, right? So you have both. So you just need to move this one over there, like this, and now you're sort of growing behavior, right? But now your rectangle shouldn't be called rectangle area. It should be called, well, now let's call it maybe rectangle. But if you look at it more, and actually let me go down, rectangle, like that. And by the way, this whole deciding if it should be one or not is actually related to another solid principle, one of those 5 solid principles called the interface segregation principle. And by the way, some people say that software development is all about managing dependencies, which is also related to this principle. But we're going to talk about this in another video. All right, so we have our rectangle now over here, right? And if you start looking at it, then it's still not really a rectangle, right? We wanted to grow behavior. How did we end up at having an object like this, right? So what it is, it's actually, so this is actually not an area, right? This is more something like of an area calculator, and this is something like scale tool, right? And now we have here area. I didn't save it. Area calculator. Actually, let me do this. Let me do like that. With scale tool, and now you see, okay, this is actually not a rectangle. This is something like a rectangle, I don't know, painter or something like this, right? Or as most programmers will call it, they will call it rectangle manager or rectangle controller. Please don't do that. This is a rectangle, okay? Right. What I'm trying to say is that if you have a language that encourages only one style, like for example, let's be more specific. Let's say you have Java, right? And Java encourages you to use an object-oriented style. There's a philosophical problem that I have with this. Even though it's as I've just shown, it is possible to write valid and maintainable projects like this. It just doesn't fit the way I think. For example, if you say knife, that even though knife has properties like dimensions or weight, I don't think about it as a knife primarily as a data structure. I think about it primarily as an object, right? Because it has behavior. The first thing that comes to mind when you say knife is cutting stuff, right? And cutting stuff is a behavior, which is also the reason why if we had a knife object in our code, probably some programmer would call it, I don't know, apple cutter or something like this, instead of just calling it knife, because objects are sort of verbs, and data structures are more like nouns. So for example, if you say dog, then the first thing that comes to mind is a data structure, right? Because even though I know that I can play with a dog, I can walk with a dog, I can the dog can play dead and stuff, primarily to me what matters is how big is the dog, how cute is the dog, how how fluffy is the dog, whatever, right? So for me, it's mostly the data that the dog has. So at least the first thing that would come to mind, the first thought would be, okay, I should probably go with pattern matching. I should probably go with data structures. Whereas with a knife, it would almost automatically come to me, that I should go with an object. Whereas in Java, I don't have this flexibility. I'm forced to think in terms of objects. And I have to be honest, I'm not a big fan of being forced to think in ways like this. But in fact, we will find out in a few videos that enforcing things is not always a bad thing. But again, these would be only my initial thoughts, right? After that, I would still need to sit down and I would need to evaluate my use case. Even though I'm a dog expert, I know everything about dogs, it doesn't give me the right to ignore the use case, right? So just knowing the domain is not helpful enough. All right, so we arrived by the end of this video, and I hope I managed to convince you that this is a very, very important topic, because otherwise you're going to run into maintenance issues that might actually kill your entire project. So pay attention to things like this too, to things like equality, to things like where you put things. And by the way, creating those multiple projects and at least enforcing that the dependency goes in the right direction is also very, 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 very important. All right, I'm talking too much again, and this video is already getting way too long. So it's been Vlad. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.